I hear doing something. So last night I watched two videos, one by Elias Experiments and one by Advanced Tinkering. They both made a gigantic still made out of stainless steel to make 1 kilo of potassium metal. The reaction they used was pretty simple. It was just potassium carbonate mixed with magnesium powder, and when heated and burned, that generated potassium metal, which then when they heated a second time, they were able to distill over into another flask and collect up to 1 kilo of potassium. That is an insane amount, and it's also very cheap to do. However, I kind of want to try that myself, but without a huge giant still that requires engineering efforts and all sorts of stuff that I don't really understand. And instead of using magnesium metal, I want to go even cheaper and try aluminium metal. So I'm just going to mix random chemicals together and hopefully I'll find something that works. Also, I don't have any potassium carbonate, so I'm gonna have to make that myself. So the idea is to turn potassium hydroxide into potassium carbonate. The way I'll do that is by bubbling carbon dioxide through a solution of potassium hydroxide and water. Now there's multiple ways to make carbon dioxide. The easiest way is just to breathe out through your lungs, but I don't know if this is accurate, but according to ChatGPT, that will take me 6 minutes just to convert 10 grams of it. And I want 100 grams of potassium carbonate. 20 minutes to 30 minutes, which is a lot of blowing into solutions of caustic hydroxide. So I don't really want to do that. So instead I'm going to be adding hydrochloric acid or vinegar, either one works, into some sodium carbonate. The sodium carbonate will react and produce carbon dioxide gas, which I can bubble through using my apparatus behind me, which is out of focus. All I need to do is weigh out 100 grams of potassium hydroxide and then basically 100 grams of sodium carbonate and maybe like 50 milliliters of HCl, maybe a little more, I'll see. That's 100 grams of potassium hydroxide. Oh yeah, it's getting hot really fast. Steaming hot. The glass would very unlikely break, but if it does, it would burn me, like immediately. That's my 100 grams of potassium hydroxide in 60 milliliters of water. So it's quite concentrated. And I'll bubble carbon dioxide through this. This is 100 grams of sodium carbonate. Just a bit over 100 grams. It's like 107. Okay. Now the top, I'll fill with HCl. I don't know how many milliliters that is, but I assume it's enough. Who knows? Yep, I just gotta open this valve up. That's carbon dioxide being bubbled through. So right now it should be producing potassium carbonate. Now, I don't know if this is actually going to fully react because I didn't measure the amount of hydrochloric acid I added. Potassium carbonate and potassium bicarbonate is less soluble than potassium hydroxide, so hopefully I should see a white precipitate forming, or it'll just look different in general. I don't know, we'll have to see. This is definitely carbon dioxide coming off. It's just, I don't know if it's absorbing it that well. And then once it's done bubbling, I'm going to take it out, pour it into a large open tray or dish or something and heat it up in the oven and be left with my potassium carbonate crystals. Look at that, I'm starting to see some crystals form, I think. The potassium carbonate is taking a while to be prepared, so in the meantime, I'm going to try preparing a thermitic mixture of potassium hydroxide with aluminium powder. Now, I've seen someone do this before on YouTube and it did produce potassium metal. They used 10 grams of potassium hydroxide with, I think, 3.5 grams of aluminium powder. So this should work. I just want to test it for myself and see what it's like before I go on to using potassium carbonate mixes or mixing aluminium with magnesium and stuff like that. I just feel like surely it's possible to do this procedure with aluminium and potassium carbonate, because, I mean, this is hydroxide, but like, I don't know why I pointed at that. I just feel like it would be better because the hydroxide has some byproducts. It kind of fucks things up a bit. Plus it's way too reactive. I'll just tap it on there. So that will be mixed with this, the potassium hydroxide here. Unfortunately, the potassium hydroxide is absorbing a lot of water, so might have been a bit too late for this. We'll see what happens. Got a bit of magnesium to set it off. Let's see if this does anything. Oh yeah. Oh nice. I see the purple flame there too. Interesting. It's like a little cake just rose. It's weird. Okay. Okay. Oh! Oh, that's so cool. It's got little carbon fireworks in it too. That's weird. There's no carbon in it though. I made a little cookie dough. That's what it looks like. So it definitely produced some hydrogen. I guess I could add some water to it and see if it pops. Whoa! Jesus. Yeah, okay. These bubbles are hydrogen. That's why it does that, like a chain reaction. Now, I don't have my potassium carbonate yet, so I'm going to test with sodium carbonate first. Sodium carbonate plus aluminium. Now this is 5 grams of each, aluminium and sodium carbonate. So I'll mix them together. They're both a powder, so relatively easy to mix together. Now sodium carbonate has a higher melting point than the hydroxide. That might be a bit difficult. Okay, let's see if this does anything. I'm guessing it won't. Oh, that's basically burned out. It's too stable. What? It didn't really react at all. Yeah, it's forming crystals all over the bubbler tube now and blocking it. It makes it hard for it to release gas. That looks freaky. I'm now transferring the potassium carbonate I produced into a wide dish that I can then put in my oven. Okay, now this is a mix of 5 grams of aluminium with 2.5 grams of sodium carbonate. I'm going to place it on a spoon with my fingers because I don't have a spoon anymore. This was my spoon. So I'm going to try doing it under heat. I'm going to try melting the two together. I mean, yeah, the spoon's just getting redder and redder. And it's really putting up a fight. What the heck? Why isn't it melting? It's just white shit. Oh, fucking hell. I am so terrible at this. It did not care one bit. Okay, well, maybe let's just blame the ratio. Too much aluminium. Damn it. Okay. Now I'm going to add a mixture which is approximately 15 grams of aluminium mixed with 30 grams of sodium carbonate. Set to 300 degrees, and then I'll slowly raise it up to 1000 degrees. 900 degrees, that's the point at which these should melt. Both of them together. Okay, I'm happy to announce it has finally melted inside. Look at that, it's doing weird bubbling or something. Check it out! Like a little pilot flame. Oh! Oh shit! Another thing is, sodium's being boiled off right now completely. It's not... If I try to collect the vapors... Oh shit. I don't know what that sound is. It's really scary though. Okay, we've gone over 1000 degrees, which is probably due to the reaction going on in there. I didn't really think about that. Oh shit. I broke my crucible. I didn't even notice that until now. Why did it break the crucible? I don't even know. Okay, shit goes weird at 1000 degrees. So I put some water in the test tube that I just filled up with smoke. I got a piece of litmus paper, and when I wet it, you see it almost turns kind of greenish purple, and that's indicative of a pH of around 11, I reckon. That has to be sodium hydroxide, I think, which is really exciting because that means I've made sodium metal. I think I'm certain of that. It's just, I don't know what efficiency it was with, and my crucible is completely broken inside. So I need to find a method to do this again at 1000 degrees Celsius. I kind of want to do it with potassium. Now these are all the parts I've gathered to make a still. First I'm just going to put it together. Okay, and that's it. So this is it put together. It's all loosey-goosey at the moment, so I got to tighten it up. Before I can tighten it up though, I got to put it in hydrochloric acid to get rid of the zinc galvanized coating on it, because once that's heated up to like 1000 degrees, it's gonna cause zinc fumes to enter the air, and I don't want to breathe that in because I'd get poisoned. So it's good to put this in hydrochloric acid. So the reactants will go in here, they'll distill over onto this side. Hopefully it's sodium metal that comes over. Now I've decided to put 2 elbow joints here because I was originally wanting to put the entire thing on an angle like this so the vapors are more likely to come over, but it's unlikely to really work that well if there's like a furnace in the way. And so I've put this second elbow on just so I can adjust it like that, so I can kind of choose just any angle I want. Now I decided to weigh out 20 grams of aluminium powder. What? No. Hey. And now finally around 40 grams of sodium carbonate. The reason I'm using sodium carbonate and not potassium carbonate is because I checked in on my potassium carbonate and it was still rather wet and I didn't want to continue waiting. Using a funnel, I put everything into my still, put all the pieces back together again, and took all that garbage out of my furnace.
Yikes.
Okay, so I've had to switch out the tube for a much shorter one. The other one was like that long. This is much shorter. But all the chemicals still fit in it, so it should be fine. But yeah, this goes in. Now I don't have any insulation up here, unfortunately, so I've just closed that on it. It's not really that good of a seal. There's gonna be a lot of heat just wasted away. Okay, I managed to attach this test tube onto it, filled up with mineral oil. Yeah, I don't really feel like putting the metal underneath the oil, because then when gases are produced, it's just gonna like spray back and shit. I don't really want that. I now need to flush out the system. Now, I didn't make an easy way to do this, but I'm gonna be putting a bunch of argon gas inside. I've put some fiberglass here, just some regular insulation. That way, gases can escape, but not so much that gases will come back in. That's the main thing I want to avoid, is oxygen coming back in. So we're just going to be doing this under normal atmospheric pressure and hoping that the carbon dioxide produced will just prevent oxygen from coming back in and flowing backwards. Okay, so I'm now filling up the apparatus with argon gas. This will prevent oxygen from reacting with the sodium when it's produced, because before putting argon gas in there, it's just filled with air and there's oxygen in the air, so it should help remove the air in there with the oxygen to prevent sodium from reacting. Flames might come out of the joints here. Hopefully not.
Not even up to 500 degrees Celsius, and there's already problems. There's water vapor coming over, and well, that's kind of scary. I don't want water and sodium metal. That would be bad. Just trying to get rid of the steam, the water vapor there that's...
Let's increase the temperature to 900 degrees Celsius, and then from there, hopefully the sodium carbonate will melt, and then I'll raise it up to 1000 degrees Celsius, and it should start reacting about 10 to 20 degrees before it reaches 1000 degrees Celsius. At least that's what happened when I did it in the graphite crucible, so we'll see if it works in the iron or not.
Okay, it just passed 851 degrees Celsius, which is the temperature that sodium carbonate melts at. Or inside the metal, it's probably less, because half of the metal is sticking out the top. But
so I've just set it to 1000 degrees Celsius, so I'm gonna move the propane torch away. Now I've put this on top of a plastic table, which I don't know why I decided to do that. There was a fume hood right there, and I have tiles in another shed that I could have grabbed, but, well, it's still rising in temperature. So I guess it is doing something. Put these gloves on just in case I need to. In case something goes wrong. Oh! I hear it doing something. Shit! God, stand back a bit. That's okay. I had a feeling that might happen. It's coming over very fast. Could just be hydrogen burning there. Actually, that was just oil. I definitely have sodium metal. I can see little metal droplets. Yeah, good thing I just put on the gloves too. Oh my gosh.
That was way too violent. In fact, it was so violent of a reaction that collected down here. There's like all sorts of shit in that. I don't think it's sodium metal. Looks like something is reacting, or that has a bit of metal on it too, doesn't it? So yeah, that kind of sprayed everything everywhere. I've grabbed a tiny little piece of the metal from inside the test tube, and I've got a bit of water here. If I put this in and it fizzes or does something, then that means it's sodium. If it does nothing, then it's aluminium. Let's see. Oh shit! Listen to it. That was sodium. Oh my god. So I've made sodium metal somehow with this. I didn't think that would happen. There's little bits of metal in places, so I don't know. I think this test is done. I don't think I need to distill anything over. I can probably just test and see if any of this stuff converted to sodium. Oh shit. I think this is just like carbon as a byproduct, so this might not be too hard to separate. This tube should mostly be filled with sodium, I believe. Oh, seems reactive. Dude, that is like a lot of sodium. Wait, what? Is there any aluminium in this, or is it just sodium? All the shiny metal bits you see in here are sodium. I didn't think that would work at all, especially with like such a fast distillation. That's gotta be the fastest distillation I've ever done. And actually have it work in the end. I've now transferred all of the product that ended up in the big test tube down here into these two other smaller test tubes. And this is just so I can put a lid on top because I couldn't find a lid for this one. So hopefully if I leave this for like 24 hours or so, it'll slowly separate out and all of the solids will be at the bottom, and then I can just pour off the oil and it should be mostly relatively clean. I'm wondering how it made sodium metal when the reaction was only going on for like 2 seconds. It didn't really last long enough to make much sodium. But that's the problem. Because I don't think it was actually generating a huge amount of gas. I think it's just that the temperature at which the reaction started was above sodium's boiling point. So the moment sodium is even made, the sodium is just completely vaporized. It just boils immediately. That's a problem I gotta fix. And I don't know how I'm gonna do that. My only thought is to lower the activation energy. This is a difficult one. I don't know what I'm doing. But I gotta clean this test tube up and see what I got, I guess. Oh, okay.